So student, now let's do some questions on the topics what we have done is related to NCERT. So this is the NCERT exercise question 3.1. In that question, EMF is given to 12 volt, inter resistance of the cell is given 0.4 volt, 4 ohm, and the outer resistance is negligible or 0. So what is the maximum current? E upon R. How can you reach this statement or the result? E upon R. Watch my previous videos. E equal to 12, R equal to 0.4, and the answer will be 30 amp. The next question 3.2. The question says you there is a cell of EMF 10 volt, inter resistance 3 ohm, and the current is flowing in a closed circuit through a wire, and the current amount is 0.5 ampere. What is the resistance of the wire through which the current is flowing? So we have a formula R equal to E upon I minus R in my previous lecture. You can watch it. E is 10, I is 0.5, small r is 3. When you solve it, you will get 17 ohm. And in the same question, terminal voltage has been asked. The formula is given E minus IR, time minus 0.5 into 3. And when you solve it, you will get 8.5 volt. So you must read the question in NCERT book, and then you can take the solution. This is an important question. This is also from NCERT. This question is related to the charging portion of the cell. As per the question, there is a cell whose EMF is 8 volt, inter resistance is 0.5 ohm. It is connected to storage of a battery whose voltage is 120 volt, and both are connected by a wire whose resistance is 15.5 ohm. Why we have taken 15.5 ohm resistor? Because it will save the cell, 8 volt cell, from the harmful effects of current. There may be short circuit, or maybe the heating effect to the cell can be damaged. So 120 volt has to charge 8 volt cell, and this is the solution. We want to calculate the terminal voltage during the charging across the 8 volt. And who is charging 8 volt? The storage battery whose voltage is 120 volt. So net voltage of the circuit is 120 minus 8, 112 volt. Current is the current equation. You can watch my previous videos. You will get the equation that from where it will come. E dash upon R plus R. E dash is given 112. Capital R is given 15.5. Small r is 0.5. Solve them, you will get 7 ampere. So the net voltage 112 volt is flowing current 7 ampere in the circuit. Now the current is passing through the cell. Cell is being charged. What is the terminal voltage across the cell? So this formula you have to remember, that when the cell is being charged, no minus sign, plus sign, because current is given to the cell, is not taking from the cell. As per the NCERT, you have to put it here plus. And what is the EMF of the cell? 8 volt, current is 7, small r 0.5. You solve, you will get 11.5 volt. So as we have learned, as we have discussed earlier in earlier videos, that in charging case, the terminal voltage is greater on the same cell, greater than its EMF. So whose cell is being charged? This cell is being charged. This EMF is E, that is 8 volt, and it is lesser than the terminal voltage. And it's a common concept. If you want to charge the cell, definitely you need a bigger battery. You can't charge the cell with the equal voltage battery or the less amount voltage battery, because the battery which has to be charged or wants to be charged cannot be charged by the lesser one or the equal one. It will be charged by the greater one voltage. Otherwise, electron cannot be accelerated, and the accumulation of charge will not happen on the cell which is being charged. Thank you very much. For further videos, subscribe my channel, and thank you very much.